This is my Physics2212 Lab 1 charge tapes. So the purpose of this Lab 1, the charge tapes, is to use charged pieces of scotch or clear tapes to observe the transfer of electrons between surfaces of the tapes, and also to determine approximately how much excess charged electrons are on a piece of charged tape. So for summary of results, I observed that the pieces of charged tapes repelled each other, and also found out that the charged tapes were positively charged. The charge on each piece of tape was 2.39 times 10 to the negative 8 Coulomb. The number of excess electrons was 1.49 times 10 to the 11 electrons. Equal distribution of charge on each piece of clear tape. I used Newton's second law and Coulomb's law to calculate the charges on the tapes. And also I used the dimension of atoms to calculate the number of excess electrons for each atom on one piece of charge tape. I utilized the concept of electric fields and also electric forces of a point charge. The system is the U-tapes, and the surroundings is everything else in the lab room except the tape. For assumptions, long tape was treated as if it is a point charge with all the charges at the center. Two tapes were electrically neutral until they were ripped off from each other. I first placed two pieces of neutral tapes that are approximately equal in length on top of the third piece of neutral tape on lab desk. Then I charged the two tapes by ripping them off of the third base tape, and tested the charge of the charged tapes by putting them close to each other and also testing them near other objects. Then I placed one of the charged tape above another until the upper tape began to float, then measured the distance of separation between the two tapes that were repelling each other, and lastly, I determined the excess charge. So before the actual results came out, I expected the tapes will have the same charge, so they are likely to repel each other. If U-tape was positively charged, it will be attracted to a negatively charged plastic pen. If U-tape was negatively charged, it will repel the negatively charged plastic pen. If U-tape was neutral, it will be attracted to the pen due to the dipole of tape created by the pen. So for actual results, two charged tapes repel one another as expected, and charged tape was attracted to my hand and other objects in the lab room. Lastly, it was also attracted to charged pen, which proves that U-tapes are positively charged. So for calculation, I basically used these two equations above on the slide. And the length of U-tape was 0.23 meters. The width of U-tape was 0.04 meters. Floating distance between U-tapes was 0.035 meter. The surface area of U-tape was 0.23 meter times 0.04 meter, which is 0.0092 meters squared. So for number of electrons, I divided the surface area of U-tape by the area of one atom, which came out to be 9.2 times 10 to the 17. So the gravitational force was 0.0041218 newtons, which is calculated by getting the gravitational force, which is Fg equal to m times g, which is 0.00043 kilogram times 0.81 meters per second squared. The charge on tape was 2.396 times 10 to the negative 8 Coulomb, which is calculated by this equation above. And the number of excess electrons was 1.49 times 10 to the 11 electrons. The ratio of excess electrons to atom was 1 to 6.17 times 10 to the 6 power. So by using Visual Python, I used green spheres and yellow spheres to represent the two pieces of U-tapes as point charges. Green represents the upper tape and yellow sphere represents bottom tape. So for possible errors, the charges on the U-tapes could have been lost due to the humidity of the lab room or due to my hand. The weight measurement of the tapes was approximated. I treated U-tapes as point charges, which is one important discrepancy between the model and the actual experiment. So what if electrons had positive charge and protons had negative charge? What would change about the observations you made with your tapes and other charged tapes? I think the results would be the same even if electrons had positive charge and protons had negative charge. The tapes would still repel each other because like charges push one another and unlike charges attract each other. Why is it important to handle the charge tapes as little as possible? What happens when the charge tapes come into contact with your hands or other objects? When charge tapes come into contact with my hand or other objects, it might regain some of the lost electrons and become uncharged. Therefore, it is important to handle the charge tapes carefully to make the contact as little as possible. So in conclusion, I think the most important part is that objects are easily charged from making simple contact, and daily objects such as clear tapes, desk, or pen could be used as point charges in a model.